Okay. This fellow by the name of Goethe was a fantastic, incredible individual. He said, Die Geschichte der Wissenschaft ist Wissenschaft selbst. Oh, I'm sorry. Let's do the magic Cody translator, shall we? So, yes! Which is that in order to understand science, you have to understand the history of science. This is what he said. He was, of course, he wrote poetry. He wrote Faust. And actually, he developed the University of Jena in Germany. And he developed a theory of light, which is fantastic, and a remarkable individual. And then once upon a time, her son and my son, we were single parents, and her son and my son were roommates. And they introduced us to each other. And they said, oh, hi, okay, let's get married, okay. And so we went on from there, and next slide. Actually, I was a flight instructor, and there's going to be a story behind all this. And she wanted to take flight lessons, and I said yes. But we decided to get married instead. The next slide. Some of you may be familiar with this book, The Discovery of the Elements by Mary Elvira Weeks. Just a classic. She wrote this in the 20s and the 30s, never having ventured to all these lands where these discoveries were made. In this fantastic book. So when Jenny said, where do you want to go on your honeymoon? I said, I want to go to Europe and see where all these elements were discovered. She said, okay, we'll do it this summer. And so we did. And it was just the beginning. Because, boy, we bit off more than we could chew. Next slide. So we started for the elements. This is in England where my brother-in-law lives, as a matter of fact. He's helped out quite a bit. Next slide. This is Romania again. It was cold there, can you tell? Next slide. Here's where the New World element discoveries were made. Not too many, but on the Old World, here we're going through the periodic table. All right, students, there's going to be a test on this. So make sure you memorize where each one of these elements were discovered. We've been to each one of these sites with the exception, for example, of zinc. Marco Polo noticed that. We have not been to Iran. We're going through the periodic table. And you notice for some of these, there's more than 2 for one element. Sometimes there's up to 9 for an element, because if where the ore comes from, the person who first found it, where the museum he took it to, the scientists first investigated, the scientists who first decided, who realized it was an element, the further characterization and so on. The story behind each element can occupy many, many, many different places. So there they were. You got that memorized? Next slide. Here we go. Well, this is an excellent time. We were blessed because this is an excellent time for starting this because, first of all, the Iron Curtain had just fallen. The Iron Curtain, which you see, goes through West Germany, East Germany, goes across. Here's Czechoslovakia, and then here's Austria, and then there's Slovakia, and then there's Romania here, and Hungary. Now we could go across and access these countries readily. My daughter and I just happened to cross over to East Berlin the day it was open. That was scary because the soldiers were still there with their Uzis, and it was spooky, but it was exciting, very exciting indeed. This is Berlin right here, of course, which was in East Germany. Well, 2, internet. This is Jenny, and she was teaching school in the Denton ISD, and she taught journalism, she taught photography, and she taught computers. These are old Macs. These are still Macs, aren't they? And she learned on the Macs, and then she learned on the IBM clone, so she knows all computers. She's an expert, and she was fantastic. And we found out that with the internet, which had just started, now we can communicate with these people across there. Instead of sending a letter, like we used to do in the 70s to somebody, it might get there in 2 weeks. They might respond to it in a month or 2 or 3. We might get a response. You got to plan a year ahead. Now you can internet immediately. And that was back before spam existed. And everybody's excited about talking back and forth. We could set up a summer over there very easily. And half the sites we visited were just spontaneous, just wandering around. Other were set up. We could be very, very efficient. Then there was her computer. Any of you ever see this? Ever work with this? Yeah, okay, yeah. And there were 2 other things timely. This, the GPS, and this, the digital cameras had just come out. here is the digital photography. And it was the very first one. She was an expert, so she could tell us what we need to do for digital photography. This new camera has just come out, which is a Sony Mavica. It's digital. And you see this little thing flopping out here? You know what that is? Well, and when you take a picture, you go, it would record it on there, and then you might get 10, 20 pictures on a slide. The optics were fantastic.
Yes.
These pictures you see here are all taken off this camera. Just beautiful optics. When you come to the new camera, sometimes the resolution is, the quality of the photograph is not as good because the resolution has to be finer and the color isn't as true and so on. There's an article about this that just came out in Scientific American. All on this camera. We did get a better camera back in the around 2005 and 2006, but this is where the majority of the pictures came from. Next slide. And here's the GPS. Catherine, you remember this? Did you see us playing with this? Okay. It still works. We bought that in 1999. And you know, the Lord works in mysterious ways. Remember that airplane you saw a little while ago? Well, my wife and I, were we married yet then?
Yeah.
Okay, we're married, okay. We were flying back from Houston, from where sister lives, and we were in the middle of the clouds. IFR, in this instrument flight rules. And all of a sudden we heard a pow! That's a sound you do not want to hear when you're in the middle of the clouds, in the middle of the night, over somewhere God knows where. And to make a long story short, the guy says, ATC says, turn left heading 350, says stand by. We just lost all our electricity. And they stand by, and they hear that. And we assessed the situation. There was a hole in the clouds. We decided we were going to turn off all our electricity. And back then, well, an airplane doesn't have to have a battery attached to it. Like the cars used to be, remember? You could actually run a car, you could push it and start it without having a battery at all. That's the way airplanes are. And we told them we're declaring an emergency, we're going to climb out, and then we're going to turn off all our, and then we're going to get a hole in the cloud, we get the detonate and come back down again. And obviously we made it. But from that we said, we're going to get that newfangled device called this GPS. Because what if we were in the soup and it went all the way to the ground and all the way up? We want to know where we are. That thing still works. There's a 10-year battery in it in 1999 and it's still working great. We love it. Okay. Well, what we could use this for is mapping, because you see, Google Earth did not come until 2005. And so we could map all our stuff, our places. It's wonderful finding your hotel. Because you're in the fog in Sweden, you know, and you don't know where you're going. So it's that way, it's 5 kilometers that way. No, it's 3 kilometers. No, it's 2. No, it's 1. Then 500 meters and so on. And there it is. It's just right there. Boom! You run into a fence. Because you have to go around it. At least we found it. Okay. Wonderful device. Next slide. Okay, here we go. And with it, you see the Da Vinci Code? It's all these plaques here. They're actually real, and they lead to the Louvre. And we took, here it is. Here's the latitude, here's the longitude, 2 degrees 20 east. And what's interesting about this is that when we were first reviewing some of our work with Humboldt, he came over to Mexico and South America to do a lot of work. His longitude readings were always 2 degrees and 20 minutes off what they should be. And I couldn't figure it out until I realized he was using, those days, before the Greenwich Meridian, he was using Paris as a 0. Because back then, Paris was the middle of the world. Culturally, scientifically, politically, always. Okay, next slide. Here's some of the maps we've developed. We've created 360 of these maps. And to give you an idea, this is Stockholm here. And with this now, you can go up here, see the arrows showing. And we put this on our DVD, and so people who want to use this can actually find the place. We're going to Rosario, the Ytterby mine. Okay, students, what element was discovered at Ytterby? There's 4 of them. 2 of them start with a Y. You can find them on the periodic table. There's yttrium and ytterbium, and also erbium and terbium. Okay, all right. But let's blow this up. Let's see it. We go like this. Can we get higher resolution than that? You bet you we can. Okay, let's blow that up. Here we are. See the scale down here, 200 meters? And you see these strange words like Feldspitzwagen, that means Feldspar Street. Here's Terbiumwagen, you know what that means, Terbium Street. Itrimwagen, that means Itrim Street. Glimmerwagen, glimmer, mica, glimmering. Glimmerwagen, and you speak Swedish? I'm sure I'm not pronouncing this very well. And Gadolinitewagen, gadolinium is an element, GD, in the middle of the rare earths. So these maps are available. Now, we have to do this because Garmin said that we could use these as long as this is nonprofit. So we set up a nonprofit organization here, which means that if we sell $500, $1,000 worth of DVDs, we have to give it to scholarship, and that's what we do. That really saves problems because we don't have to do any paperwork now. It is just glorious. No royalties, no nothing. We just grab fellowship, whoever we want to give it to. Lovely. Next slide. GPS readings are on here as well. Scale is down here in all our maps. Next slide. Let's go on. Let's go up to the inner mine. Wonder what it would be like. Well, okay, here's a sign here. Here's the road. We go up there, go up to the mine. What did they used to mine there? Well, they used to mine quartzite, and feldspar for the porcelain industry. Great Britain and Poland were both doing a lot of porcelain. But in here, you would find a vein here of the rare earths, where the yttrium and the terbium and the holmium and other rare earths were found. Oh, it's just so exciting to find that. Now, we in our rock collection at home, we gathered samples of this quartzite and feldspar at home. So we have it in our cage, so you can see this is actually what they mined here. The mine is closed now. Next slide. Now, I'll give you an idea of some of the excitement of going back during these days. This is the second Royal Swedish Academy of Sciences, where Mosander discovered lanthanum. You know where lanthanum is? Over there at 57. It's one of the rare earths, essentially. And here's a church. Here's the academy over here. Here's just some buildings over here. And so, well, what did it look like years ago? Let's see. Look at that. It's a painting we found. Here's the church. Here's the academy. Here's some other buildings over here. Go back one. See it again. Yeah. Thank God for churches. Because they've been there for hundreds of years. And you can find a place. I mean, all the other buildings are torn away, but you'd always find the site where, because you could identify the site because the churches were there. Okay, very nice. Next slide. Okay. Let's go wandering around. Anybody ever been to Germany? Heidelberg, by any chance? Heidelberg. Well, if you go down the Hauptstrasse, which means the main street, you'll see this huge statue of Bunsen. He invented the Bunsen burner. I need to tell you a story here. You have to be very careful about your nationalistic statements here, because if you're in England, somebody told me Bunsen didn't invent the Bunsen burner, Faraday did. And you run into this sort of thing all the time. When we go to the French, we go to France, all the French are wonderful, they invented everything. We go to Great Britain, all the Brits are the smartest people ever was. When we go to Russia, oh yes, the Russians invented the airplane first and all this stuff. That way you get along with all these people very well. And another thing is, Americans are classless. They have no class, so we can mix with any culture whatsoever. And that came in handy. Let me tell you a story once. My sister used to be a professor at University of Warwick. We had a garden party once, a big long table from here to about 60 feet away. And at this end was the CEO of the hospital. At the other end were the janitors and the garbage collectors and all that. And up here, the CEOs were saying, oh, I've just been to France where I had this most exquisite wine there ever was. And here, these people are saying, well, I smashed that guy's face in the mud when we were playing rugby the other day. Entirely different topics of conversation. And you saw a gradient all the way up there. But they're all useful, because these people could tell you how the farmers did it and why the mines were made. These people could tell you how the science was done at the academies. And we could mix with everybody. And they would never talk to each other, ever. Very interesting. So, thank God we're Americans, right? Okay, next slide. Okay. Bunsen had huge hands. And when he blew glass, it seemed not to hurt his hands, so that his students reported smelling charred flesh when he was blowing glass. And he invented the Bunsen burners. Why did he invent the Bunsen burners? Not to heat up pots of ether, but instead, when he's doing spectroscopic analysis, he had to have a colorless flame. And he invented the Bunsen burner and the blue flame instead of the yellowish flame. So when you stuck metal, you've done this, students have, when you stuck metals in here, you see red through this element, green through this element, and so on. He invented it, he and Kirchhoff. And these universities are proud of their heritage. And they have these displays, and this is the Hörsaal, which is German for a lecture hall, here salon, which means a lecture hall. And you speak German, you see the connection here. And all these displays here, all the inventions, all the important peoples, and one of them, when you go in here, there is the, anybody speak German? Doesn't matter, you can speak German, look. Cesium, the element 55 by Bunsen entdeckt. That means discovered, original preparation. So that's the original cesium that he prepared. And there it is. It's kind of cruddy because it's oxidized, but there it is. There it is. If you get a pure sample of cesium now, it's yellowish. And if you hold it in your hand under argon, the seal too, it melts in your hand. I've got a 5-gram sample of cesium that I'm going to throw in the lake when I retire. And see where cesium way below sodium? Students, you know what happens when you throw a chunk of sodium in the water? Well, that goes. I had a student who had a Graham's vial, and she dropped it in linoleum like this, and it blew a hole in the linoleum. It was glorious. Blue flames. Oh, it was fantastic spectroscopic experiment. Okay. Next up. Here's his original spectroscope. He burns it over here, goes to the prism, comes out here, and then he can record the lines in the spectrum and identify the elements. Of course, he discovered rubidium and cesium. Next slide. Okay. Now, where was this done? If you're walking down the Hauptstrasse, remember the Bunsen statue? It's right over here, and we look across here, and there's this old schnapps factory. And it was turned into the university in the 1800s. And we're always looking for plaques. Always looking for plaques. There's a plaque, Jenny. There's a plaque. Okay. Here's a plaque. That's not important. There's a plaque. That's the guy who invented the schnapps factory. There's a plaque. There's a plaque. And there's a plaque over here above the beer truck. What does that say? Very important. Very important plaque. Now, if the hair doesn't rise in the back of your neck when you read this, you aren't a chemist. Because this is written in very classic German. But I'll go ahead and try, because it got the verb way down here and the modifiers and all this, and you've read German. But I'll translate it for you. It says here, is in this place, Kirchhoff, in 1859, he founded spectral analysis with Bunsen, and thereby unlocked from the sun and the stars the secrets of the universe, the chemistry of the universe. What more can you say? Yeah. And he was right. Because now, then people looked at the stars, they could identify the elements, and helium was discovered in the sun soon afterwards. Next slide. All right, this is slightly somewhere else, isn't it? Don't you take good pictures? And if some of you ever been to Berkeley, anybody? Okay, Berkeley's over here. You go by Alcatraz, right? And then Berkeley's over here. And if you go there, you'll find some very interesting stuff there. This is Al Gyorso. He died very recently. He's a magnificent, wonderful person. He never got a PhD in his life. And he discovered more elements than any other person. More about that in just a second. He was a technician of Seaborg. Seaborg's the guy who discovered neptunium and plutonium and so on. There's an element named after him, Seaborg. It's 106 SG. And he was still doing research in his 80s. He was doing these carbon nanotubes, which are new back then, seeing fancy things they would do. Just a fantastic individual. When we went to London to the Guinness World Records the guy asked us to come up there, but we happened to be visiting. He said, "Is it true this guy Al Giorso has discovered more elements than anybody else?" Yeah, yes. Let's see. In fact, if you look at here is the page, 2002, and right here. Let's blow it up, Jim. Let's look at this. Yeah. Yep. So you don't have to get a PhD, Sue. But it helps. But if you're a genius and work hard and at the right time, in the right place, and lucky and all that, then you can do this. Next slide, yeah. Let's go to Paris. What the heck? The Louvre? Any of you visit this place? Yeah. This is new, the pyramid is fairly new. The Arc de Triomphe. And this tower is really an eyeful right here. Oh. And let's get some more scenes. What do we see here? Okay. This is the shots that she's snapping as she wanders around. She walked in that shop and bought some stuff. You bought some shoes there, didn't you? As I recall. Okay. Next slide. Okay. More. Playing chess at Luxembourg Park. Lutetia was the old Latin word for Paris. There's an element named after it, lutetium. And there's an old meter stick. That's the only one left in Paris. You see, back when it was invented, the metric system was invented, they mounted copies of the meter stick all around Paris, so that the farmers would come in and measure with their string and go home, so they have a common unit wherever they go. We've discovered this in a lot of countries. In Palermo, Italy, they had one of these. They had old palms, measuring the height of something. They had the metric system right next to it. Fascinating. Next slide. This is the only one still existing in Paris. Next slide. Yeah. You see statues like Nicolas Louis Vauquelin, who discovered beryllium and chromium. Here he's holding a chromium there. Fluorine was discovered just around the corner here. Next slide. Now, this is an old map of Paris. Some of you have been to Paris, so I have to acquaint you with this. This is interesting. This tower was, as people passed by here, and then they had this, and there's the church, Notre Dame. It's there, Notre Dame is there. And see the Bastille up there? See the Bastille up there? I can't reach that far. And the Sorbonne is over here. And how many bridges? We got this one, you got this one, you got this one, and that's about it. You notice there's little buildings on that because the bridges then would have houses and shops, like we saw in Florence, right? Have you been to Florence to see the little shops and the bridges there? Okay, same. That's old-timey stuff. Next slide. Now, a fellow by the name of Turgot was asked by the King Louis to make a map of Paris in detail. So this is what he did. This is 1739. This is what he did. Let me acquaint you again. There's a couple more bridges here, okay? There's Notre Dame, see right there? And the Bastille is up there. Did you see it? Let me get the yardstick. Maybe. Okay, guys. Make sure you see it. There's the Bastille up there, okay? There's the Bastille. And you say, what? So what? It's the broad painting. Wait. Do it. Let's magnify. Let's expand this. What do we get? Okay. Here's Notre Dame again. See the church? Here's the Sorbonne. We'll see that in a minute. Here's the Jardin du Roi, which happens to be the garden of the king. That's where they grow their herbs because that's how they get their drugs back then. They grew plants. We're going to be seeing that in a moment too. We're going to see each of these places. Let's look at Notre Dame. Any of you visit here? We discovered how to get into this place free. we just followed a little group of Japanese tourists. And we decided we may get struck by lightning. So we bought a votive and lit it. So we're alive. So we're okay. All right. Let's see what Turgot did to this. Okay. All right. See it again? It's up there. Okay. See way up here? Okay. Let's expand that. Good grief. The whole city's done this way. Looky here. There's Neue Notre Dame, and there's Christophe here, in Parvis Notre Dame, Saint Christophe, and we can go further than that. Here we go. Good grief. The whole thing. We can go further than that. It's Quasimodo. Yes, nowhere to go. Excellent. Isn't it fantastic? Let's go to the Sorbonne. Sorbonne is a 1,000-year-old university. And we go here, and this is the Sorbonne right here. And we were lucky enough to be able to go there before 9/11. We could just walk in. And she was scared to death. We were walking and taking pictures. And Madame Curie gave her a talk and all that. After 9/11, they wouldn't let us in there. 9/11 just changed everything, unfortunately. But I want you to see this clock here, the cupola here, and the clock here, and the same thing. We're going to look this way. This is 1739. Let's look at it today. Same thing, see? Except for the erected statue of Louis Pasteur, who's in the 1800s here. It's so old here. I mean, you see courthouses here, say, oh, this courthouse is 100 years old. This is just nothing compared to these buildings. Next slide. Okay. Now we're going to go look this way. Again, let's look at this way. Let's look at it today. Here it is. Looks like this. Okay, here we are. See the clock up here? See the cupola? The same thing. It's a charming little place where the students come, have their lemonade, things like that. Here I am. Jenny's taking the picture. These are colleagues. This is Dr. Jerry Dobson, who's University of North Texas. He's retired. Next slide. Let's go to the Jardin des Bois, Jardin des Plantes. Goodness gracious, it's a mess. No, let's see. Let's expand this. Let's expand this. We're going to make sense out of this. Here's do it. Lavoisier. Have you ever heard of Lavoisier? He's the father of chemistry, the first one to say that the elements were not fire, earth, water, and air. He did it's a nice theory by Georg Ernst Stahl. Let's see if the theory of phlogiston, let's see if the theory of phlogiston is real. I bet you some of you never heard of phlogiston. That's a principle that's given off during a fire. He reacted phlogiston, which is actually hydrogen, they thought it was phlogiston, and dephlogisticated air, that was oxygen discovered by Priestley, to see if you get phlogisticated air. That is, when you mix sugar with unsweetened tea, don't you get sweetened tea? So if you mix phlogiston with dephlogisticated air, don't you get phlogisticated air? Nitrogen. He did not. He got water. He said from that, wait a minute. He said, voila. He probably did say voila. He said, zut alors. He probably did say zut alors. That means that water is not an element. It's a compound. And from there, everything else fell out. He identified 30. And he was trained right here. He went from Rouelle. Rouelle was the guy who first understood salts. Next slide. We're going to explore some more here. Here's the amphitheater. Good grief. 1739. Is it still here? Let's find out, Jenny. Is it still here? Well, this was only 150 years ago. Now and today, it is, it's there. And they were remodeling when we were there. Just incredible. You walk around Paris, you just soak in age. Every grain of dust that you see has been touched by thousands and thousands of people over many generations. Here's an interesting building here, Jenny. I wonder what that is. Well, we wander around everywhere. We get in trouble. Let's see what happens. There's a plaque. There's a plaque. Okay, let's see what it's. Now I have to speak. Now we have to read French. You can read this, can't you? In the laboratory of applied physics, the Museum of Applied Physics, Henri Becquerel. And if you look at the back of smoke detectors, you'll see units of microcuries and kilobecquerels. He discovered radioactivity the 1st of March, 1896, in here. Okay. He did it because he had a rock here, and he had to put it in a drawer next to a photographic plate that was covered, and the plate was fogged anyway. Whoa, this must be a special type of phosphorescence. It wasn't. It was radioactivity. Now, Madame Curie was the one who named radioactivité. She named it. But he first observed it. Next slide. Here's an old movie, a Madame Curie movie. I teach a non-science majors course. And this is a fantastic movie to show how science works, in my mind. First of all, it's accurate. Every building in there, every little piece of instrumentation is exactly like it was then. In fact, they had Eve Curie, who was her daughter, who was a consultant on this. She just died recently, didn't she? And so there's Becquerel, and there is Walter Pidgeon, Pierre Curie, and there's Greer Garson, Madame Curie, and they're looking at this, and he just explained that he's fogged this slide, right? Okay. And so she says, here is the rock. So she decides to see the rock, and then I wonder what's in here. And so she did her master's thesis to see what was in there. And it became so important that her husband changed his area, which was magnets, Curie point, magnetism, and joined her because her work was so important. She was right. Now, some people say, this obviously this is a beautiful example of teamwork, right? Teamwork, where he designed the equipment, the physical equipment, because he with his brother Jacques had discovered piezoelectricity, and she's the one, the driving force. He wanted to know what was in here. Next slide. And so there they were, stirring away. These big pots. This is from the movie. Fantastic movie. You've seen this movie. It is fantastic. Next slide. So we decided we'd go down there and we'd see the museum. I have to tell you a story here. Our very first year we were going to go down to this museum, and we had an appointment there. And we got up in the morning, all ready to go to take the metro, the 8 kilometers over to this museum. And we got there, and there was a big gate down. What is this? And they said, on strike. On strike? Who's on strike? Tout le monde en grève. Which means all the world's on strike. Everybody's on strike. What? And so the buses are on strike. And you couldn't get a taxi. And so what we're going to do, we asked the proprietor of our hotel, what are we going to do? She says, well, I guess you better use the foots. So we decided to use the foots. And we walked 8 kilometers, which is a blessing. Because I said the Lord works in mysterious ways. Because first of all, we became acquainted with Paris intimately as we walked all the way across there. And secondly, when we got there, they were so impressed that Americans could walk more than 2 blocks. That they brought us in and they gave us the King's Street, the next slide. And in here, there's the street. So we walked down the Curie Museum, went down, there's the Curie Museum there. You can go in there now, go into the museum itself. You'll see the equipment. This is the equipment in which they made the instrumentation. It was not a Geiger counter. It was a very complicated device which he invented for her. And next slide, the notes were still radioactive. We took a Geiger counter. Remember, did you see the movie, Dun 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 Dun, or we mentioned the radioactivity? We take our Geiger counter everywhere with us. That's how we find these radioactive watches. We go to an antique shop with a Geiger counter. We go around all the watches. What's that? Oh, your watch there is radioactive. I better get rid of it. Yeah, thank you very much. So we pick up one of the old radium clocks there, watches there. Okay, next slide. And so they let her hold her smock. They were so impressed with Americans. Okay. She had 2 smocks, and she was so diminutive. And there she is holding it. We got a lot of mileage out of this picture, I guarantee you. Yeah. It's still radioactive. Next slide. And here's where the place was. It's now a motorcycle parking area because it's so radioactive where they did their work. Remember the pots? They're doing this. They had to tear it down. Okay. Next slide. This is what it looked like. This, in the movie and the actual photograph, are identical. It's just a marvelous job of making it look like the real thing. Next slide. In the movie, not only is authentic, but it shows you that the scientists, with their hopes and their fears and their disappointments and their joys and their frustrations and their ecstasy when they make the discovery, and how they came through the final solution to figure out why uranium ore was more reactive than uranium itself. There was something else in there. And they found it, radium, next slide, and polonium. And the guy took us around and said, look, here we are, look at the eyes. Look at the eyes. Look at Pierre Curie, so romantic, so poetic, just like a Frenchman. And they said, look at her. Her eyes are hard, just like an American. But she was actually Polish. We went to the Polish Museum. She'll tell the story. We have to deal with a lot of languages. When you can't deal with it, you just got to deal with one way or another. So there we were at Warsaw, Poland. That's where the Curie Museum is in Poland, in her birthplace. And there's a picture there, like McDonald's, where you see the pictures of this and this and this, and you say, well, that looks pretty good, I think. And so we said, what is this? And she talked in Polish. And so she said, what is this? I said, buck, 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 buck. And she said, oh, yeah, yeah. Just like where we ate. We ate at the Cork and Pig, right? Next slide. Okay, here we go. All right. Here is the, how are we doing for time? We're going to be just about right. This is the largest permanent periodic table in the world. And it's in St. Petersburg, Russia. Here is Mendeleev, a statue of him. It's very interesting because he was in charge of the vodka industry in St. Petersburg. And he was deemed more important for that than he was for his work at the university. In fact, he had to leave the university and go to the Metrology Institute, where he did more of his work here. Let's blow this up. Let's see the next slide. Let's look at this. Now, you read German. You read French. You ready to read Russian? Well, you can do it. What do you think this says? Mendeleev. Mendeleev, and this is the Systema Elementa Periodical, so it's periodic system, the elements, the organization. So, okay, you can read Russian, see, okay. And you look at the elements here, and the ones which are in red were known during Mendeleev's lifetime. He died in 1907, I believe, and this was built in 1930. So the blue ones were discovered since then. Okay, what does J mean? J, what symbol would that be? Look where it is. Remember, it's like the German Jod. J was an I. This is an I. It's like iodine. But this one, I'll give a free platinum gold iridium coin to the person who can tell what JL is. I better be careful here. What in the world? JL. It's niobium. Isn't that where the PM is right now? The PM, promethium. Well, this is illinium. Because in Chicago, they thought they discovered a new element, illinium, and they actually had something named an IL, illinium. And this day, they actually took it on face value. Yeah. Illinium. Remember this? Yeah. Okay. Oh, very interesting. Okay. Let's go on. Here he is. Dmitry Ivanovich Mendeleev. This is the patronym here. Those of you who read Tolstoy and others know that the patronym was always after your father's name. If your father's name was Ivan, then your middle name was Ivanovich. So you tell what's the name of somebody's father. Next slide. And so there we were, and our guide, who was very, very professional, said, oh, you're interested in science and Mendeleev. Did you know there's a Mendeleev vodka? You cannot buy this in the United States. I've never seen it. And only in St. Petersburg. And I understand it's Rutka. That's what I understand. But we got this home unbroken, both the glass and the seal unbroken. But when I retire, when I pitch that cesium into the lake, we're going to toast some of this Mendeleev vodka. I probably, what should I do first? Drink the vodka or pitch the cesium? I'm not sure. And there's no doubt about what it is. There's no doubt about what it is. See? Okay. And our Russian technician who runs the X-ray equipment, he says that this is marvelous de-icer for windshields. And it's cheaper than our de-icer. It works fine, okay. And all this. What's also interesting is that they don't have the same symbols here because they name it after Russians here. This is Rutherfordium actually, but it's after, this is vodka. You can read that, vodka. And what's interesting is if you take out the K, is voda, which means water. There's very little difference. That's true. Next slide, that's half a kilo. And if you get a close-up for it, close-up over here. Stonium, yeah. Next slide. And here's in Freiburg, Germany. And we were just standing in a corner here. And there's Jenny. I took a picture of her. Let's see what we see there. Here's Oliver Sacks. Over here, Oliver Sacks. He's a fellow who wrote Man in the Stick, his wife for Awakenings. He's in the movie. He's a charming, beautiful man. And it was his birthday. He invited us to a birthday party in Manhattan, and Jenny's never been to Manhattan. But we had to go to Europe. And he's a person who wrote Uncle Tungsten. Uncle Tungsten, the story about his childhood joys with chemistry because his uncle had a light bulb factory. So he could play with the tungsten and other elements there. He said the most pleasant experience he had was blowing off the eyebrows of his brother. Marvelous fellow. Next slide. He visited our home once. Now what we've done is that this goes over about this far over here. We decided we were going to collect elements from each one of these sites. And so we have a sample of an element. So you were talking about getting pictures, and we might be able to help you there. Not only that, but we got a sample of the ore from each one of the mines. From the original mine, which had the element in it originally, we're very lucky to get this. We finished this up. And there's a display there. He went through every element. He loved this. Oh, well, let me play with this. Let me play with this. Oh, there's the gallium. You know what gallium does? It melts in your hand. So I said, will you fix me up a cup of hot tea? So he fixed up a cup of hot tea, plop, and goes the gallium, you know, and it melts in the bottom, and he drinks up the tea. He knows it's not poison. It's not like arsenic. And then he says, okay, do you have an ice cube? Put ice cube, and then he froze it like that. I didn't know this. We had a sample of bismuth rod. We hung it from the chandelier. And we had a big, strong iron boron neodymium magnet. Those are the real powerful. And you put it up to the rod, and as he did that, then the rod would be repelled by it like this because it's diamagnetic. Just marvelous. He knew all this stuff. Just a marvelous fellow. Okay, we're about done, aren't we? And he wanted to have directions for getting to Shaler. Now, Shaler was the person who discovered oxygen simultaneously with priesthood. To me, Shaler was the smartest chemist there ever was. And he never went for glory, never went for any awards or anything. He was asked to go to the university in Uppsala. He said, no, I just want to stay in my little pharmacy in Schrepping, little village where he was. This is in Schrepping right here. It's called K-O-P-I-N-G. It's two blocks over Schrepping. It's a Swedish word for shopping or a marketplace. And Oliver Sacks laid flowers to the grave of Shaler there. Shaler discovered all sorts of elements, and he discovered hydrogen cyanide, things like that. You could read in the original German, and when I smelled the hydrogen cyanide, it was Swedish and made me faint. They also discovered hydrogen sulfide, and he smelled that too, and hydrogen fluoride, and barium, and a number of other elements he discovered as well. Just a genius, some of these people. We've done it, haven't we? It's about, we've done about an hour. Next slide. We're about done, aren't we? Yeah. Now, you may be also interested in this. For your periodic table that you wanted to, you were doing it. Where we put actually symbol. Once you go back, can you get rid of that? Is it possible? Or does it do it automatic? Okay. We've done this for our class too, because our non-science majors would rather remember banana-onium as opposed to potassium or saltonium. They remember that. Or manic depressive pill-onium, lithium, or tethonium, and then they have a big, lot of fun. Dinosaur-onium, remember that? That's iridium, which told us that a meteorite came in, and so on and so on. And then they actually see faces of all these people here, named one after the other. There's Curie, Einstein, Fermi, Einstein, Mendeleev, and Nobel, and Lawrence. He invented the cyclotron. Remember way back at Berkeley? That's how all those elements were discovered. And then Rutherford, nucleus of the atom, Seaborg, is the only person for whom an element was discovered while he was still alive. And then Bohr, the shells of the atom, and Lisa Meitner, who first split the atom. And some of you may have seen the story of her when she had to flee Germany because she was Jew and went to Sweden. And from there was the first person to understand what was happening when splitting the atom. Very, very interesting. Now in Germany now you can actually have a hall devoted to her. And that's all the people, isn't it? Okay. We're done, aren't we? Is that it? Let's see the next slide. I think we're done. Well, more to come, to be continued. What we've done.